In every corner of the digital world, from the operating systems that power our devices to the engines that drive our games, C programming plays an integral role. It's a language that has stood the test of time, shaping the very fabric of technology as we know it. Delving into the realm of C programming feels like peeling back the curtain on the digital world, revealing the mechanics that keep it ticking. It's a powerful, flexible language that has been used to create everything from operating systems to software for medical devices to video games. So why C programming? It's all about control. It gives the programmer more control over system hardware and memory than other languages, making it a powerful tool for creating efficient programs. Now, imagine a toolbox. C programming is like the screwdriver in this toolbox. It's compact, versatile, and can be used in a variety of situations. Just as the screwdriver tightens and loosens screws, C programming manipulates data and controls the flow of information within a computer. To understand C programming, it's important to grasp the concept of variables. Think of a variable as a container that stores a piece of data. It could be a number, a character, or a word. In C programming, declaring a variable is as simple as specifying its type and giving it a name. For example, to declare an integer variable named score, one would write int score. This line of code is telling the computer to reserve a spot in its memory to store an integer that we've named score. To assign a value to this variable, one would write score equals sign 10. Now, whenever the computer sees score in the code, it will understand that it represents the number 10. Output. Another key concept in C programming is the function. A function is a block of code designed to perform a specific task. It's like a recipe. You give it ingredients, inputs, it follows instructions, the code, and it gives you a result, the output. To write a function in C programming, one starts with the type of output the function will produce, followed by the function's name, and then a list of inputs inside parentheses. For example, a function that adds two numbers might look like this: int add int num1, int num2. This function takes two integers as inputs and returns an integer as its output. A function isn't just about inputs and outputs, though. It's also about actions. Inside a function, one can write lines of code that manipulate the inputs and produce the desired output. In our add function, this might be a single line of code: return num1 plus num2. This line is telling the computer to add the two input numbers together and give the result as the output. In the world of C programming, understanding variables and functions is like learning the alphabet and basic grammar. They are the building blocks that allow us to create complex, meaningful programs. In this discussion, we've peeled back the layers of C programming, shedding light on its importance in the digital world. We've explored the control it offers, likening it to a versatile screwdriver in a toolbox. We've delved into the concept of variables, the containers that store our data, and we've examined the role of functions, the recipes that dictate what our programs do. Remember, learning to code is a journey. It's about understanding the tools and how to use them, not just memorizing lines of code. So whether you're a beginner or an experienced programmer, keep exploring, keep learning, and keep coding. Because in the realm of C programming, the possibilities are endless.